Okay, so we've done mirrors. We've done mirrors. Now we need to do lenses. So here we have a concave lens. We know it's a lens because there's an actual three-dimensional shape. But again, we're going to treat everything the same. Now what's different about lenses is rather than with the mirrors where I gave you the center and you found the focal, I give you the focal and the center is just the center of your lens. Okay? However, our light rays are still going to act 100% the same. So, if my light goes parallel to the optical axis, it's going to go to the center of the lens, and then it will refract rather than reflect. It will refract as if it came from the focal point. So my light travels through this time instead of reflecting backwards. My second ray still acts the same, and it goes through the center of the lens. These two are never going to intersect, so I need to follow it back. Okay, and this is my determined intersection. The bottom will act the same. Goes to the center, refracts as if it came from the focal point. And since I had to follow back once, I'm just going to go ahead and follow back again. And then lastly, the ray through my center point. Find my intersections right about here. Guesstimate my image. So a concave lens, there's only one option for a concave lens. It will be a virtual, reduced, upright image. Always. That's the only option we have for the concave lens. It's used for things like glasses and for lenses for things like cameras and stuff like that. Anything where you want to have a wider range of a wider view, we'll use a concave lens. With the convex lens, we're going to have two options. Now I give the focal point on both sides. However, this is the focal point that we actually care about. My center is the center of my lens. Okay? Again, the light rays are going to act completely the same as they have for both lenses and mirrors. Parallel to the focal point. And then through the center. Giving me a natural intersection right there. Do the same thing for the bottom. Parallel. Through the focal point and through my center. I have an intersection right there. Now again, I need to look at where did the light end up, where did it start, and where did it end up. It started at the top. The blue started at the top of my object, but the intersection is below the optical axis. The green started below the axis, intersected at the top or above the axis. So my object, or my image, will be inverted. So when you have a convex lens and you are behind the focal, okay, because this is a focal point as well, even though we didn't use it for drawing our diagrams, it is still a focal point. So if we have an object behind the focal point, we will end up with an inverted real image. Again, the size depends upon how close or far away the object truly is. So these two are actually pretty close to being about the same size. So do not have a size change there. All right, last one. Convex lens. This is in front of the focal. Okay? So again, that is a focal point. I don't label it because I don't want you guys to get confused. You always use the focal point on the opposite side, but it is a focal point. Get my center. Light travels parallel, then to the focal point. Remember, it passes through the focal point because this time it's a lens, and then goes through the center. Those two are never going to intersect, so I have to follow it backwards. There's my intersection. Same thing for the bottom, through the center, and then angled to the focal point. And through my center. There's my intersection, and I guesstimate my general shape. So for a convex lens, when the object is in front of the focal, you will always have a virtual, magnified, upright image. Okay, and that's how we draw all of our different ray diagrams.